Hello, my name is Evan Rogers, and today we're going to look at the Canon new FD 24mm f2.8 vintage camera lens. But we're not just going to look at it from the standpoints that most people look at them, which is analyzing the sharpness and looking at some sample images. We are going to do that, but we're going to do it with my new open source software, the Lens Analysis Suite. It's going to be super cool. And not only are we going to look at the Canon today, we're also going to compare it to vintage Nikon, Olympus, Contax, and Pentax 24mm f2.8s. So which of these and the Olympus on my desk is the best? Well, ladies and gentlemen, I created some software to answer that specific question, and having done so, realized that it doesn't actually answer the question, and you will see exactly why here in just a moment. But before we do that, one of my major criticisms of lens videos is that they don't show enough pretty pictures. So we're going to take a small intermission right now and look at some pretty pictures from the Canon NFD 24mm f2.8 as a palette cleanser. Then we're going to come back and look at some charts, and it's going to be awesome. Again, Editing Evan here. I don't know what happened, but I just lost a clip of me explaining the software. So basically, TLDR, the software splits an image into tiles. You can set how many tiles you want for the resolution of the heat map mostly. And it'll find out how sharp or in focus the tile is using Laplacian analysis. I don't want to really dive into that in this video because it's like a really interesting algorithm that you should look into. It's super cool, but it's very difficult to explain. To test these lenses, I used a test chart like a certain distance away, and then went through all of the f-stops. And then I also went out into a real life scenario of a bridge and just shot the same scene with all the same lenses. They're all the same focal length, more or less. So just kept the camera super locked off and used a real life scene. And well, because these scores I was getting were so different from those two scenes, I had to implement a calibration phase to make the scores work, because the scores are very different, but they still express the same thing. They're just an order of magnitude different. You know, if you've done stats before, you know what I'm talking about. Some statistics stuff. So yeah, this tiling-based approach gives us a lot of advantages. So we can use those tiles to generate a heat map, which is really convenient for analyzing the character of the lens. It gives us a score for each of the tiles, which allows us to get the average of all the tiles, the minimum and the maximum and the standard deviation. So let's explain what's going on with the heat maps just really quick with the Canon f2.8 wide open data. So this is shot at f2.8. So on the right, we have the sample photo with the grid and the scores overlaid. It's a little bit difficult to see with the test pattern, but what this allows you to do is just verify that everything looks legit. And so, you can see that we've got 5.5 in the top right on both images, 9.3. So it's just a different way to visualize the same data. But it's good to have the original one with the overlay so that you can figure out what's going on. Let's see here. So on the heat map, this is just a really good way of visualizing the area that's in focus. And you can see that the area that's in focus here is slightly skewed to the left, and that's just because my camera was a couple of degrees off when taking the sample picture. And so for that reason, I would recommend putting your test pattern on the wall, and just so that you can eliminate some of the axial, off-axis wonkiness. I had these two things on a table, so that's why it looks why it's so crazy. So it's more valuable to look at the heat maps in the context of the other heat maps at different f-stops. So if we look at the f4 heat map here, a lot of things are changing. First of all, we still have the same general area that's very large and in focus, but we're seeing a lot of hundreds in here, and I just want to explain that a little bit. So what that means is that when the software runs, it goes through and tiles all the images at the same time to find out what the absolute minimum and maximum are. So from the entire data set that you're comparing, it's looking for the lowest score and the highest score so that it can calibrate the whole software. And so when we see 100s here on the Canon, What that means is that like those little squares are coming out at the highest value measured across all the lenses and all the f-stops. And so also, just FYI, if you only run this on one lens, it will do the same calibration just on that lens. So, you know, it still totally works with just a single lens. It's just going to derive that highest possible calibration value from just that image set instead of the entire image set. So because we are doing a cross comparison here, that's why it's important to calibrate across all of them as well. You know, once you start like doing benchmarks, some of these things become crazy. Yes. So so the heat map is just a great, fantastic way of looking at and visualizing what's doing really good. And you can also visualize diffraction. You can have a, like, when you go up to these larger values, it is extremely evident, like, what is going on with the diffraction. Now, you might be wondering, like, what's going on with these, like, we're looking at the F16 sample here. What's going on with these 35s? I would say just, like, keep in mind that the color, you know, don't let the color of it necessarily sway you, because it's much darker blue, but it's only like 10 points away from the next adjacent one, and also similarly like almost 10 points away from the left hand side too. So it's not that crazy. It's like software is not like dying. So the biggest thing that I took away looking at all of the heat maps for all of these lenses is that the Contax Zeiss lenses they're just wickedly sharp in the center, but they have very small areas or fields of focus when they're wide open, and also when they're stopped down a little bit too. But what this means in like practical terms is that the Canon, in my opinion, is just a more practical everyday lens. You know, you want the entire field to be in focus if you're just like walking around and shooting sort of casually. However, the Contax lenses, they feel very deliberate. Like they have a purpose. They're designed to be so sharp in the center with extremely serious fall off, like sharpness fall off to the edges. I think that's completely on purpose, because you got to remember that the Contax lenses were made much later. And so, you know, given the fact that they're really expensive and they're heavy, they're like really, really heavy, I would say that they're much better suited for video work. And that's awesome. It's cool that we can like see that through the software. But let's move on to some of the comparative like data analysis aspect to this. So I'm pulling up my little notepad here, and yeah, let's look at the results for 2.8, aka shot wide open, and like what do these numbers mean? So the Canon got a 42, and then the next best was the Nikon. What is that? So what does that mean? Let's just decode that really quick. What that really just means, that's a reflection of the field that we were talking about earlier. Because so much of the frame is relatively in focus on the Canon, that's why the average is going to be like lifted. You know, the median definitely has value, but it's not as illustrative, I think, as the maximum. So because all of these lenses have been incorporated into the calibration when you first run the software, when you get a max value of 87 for the Canon, that is essentially the measure of the maximum sharpness anywhere in the frame at F2.8. And what that means is that like since the Contax, both the 25 and the 35 millimeter just scored 100% at the max, that means that at its sharpest point, the Canon is 13 points softer than the Contax. But again, you have to consider how much the Contax costs, and like whether like does that level of sharpness matter? Is that level of sharpness critical for your application? And do you even want that? Because we're talking about vintage lenses, you know? So that's that. And then, so like, that's cool. The Nikon is fine. You know, the Nikon has a smaller area that's in focus, but it scored a 77, which I think is fine because it costs very little. And, you know, do you need the focal length or do you need the sharpness if you're spending like under $200? But that's just wide open results, right? So let's sort of like skip right to f5.6 because we have we have 4 of these lenses, no, 5 of these lenses with 100% scores. The maximum here, every one of these bad boys is hitting 100% at f5.6. Very interesting results. Like the Olympus is not. It's only hitting 90. We don't hate on the Olympus though, because like it does actually sharpen up even more at f8, f11, and f16, which is insane. So it's like a different use. It's like a different case. It's like a really small lens that sharpens up like really in a really interesting way at higher f-stops, which makes it like a really interesting travel lens because it's very small and very light. And even though it's absolute dog water at f2.8, it's much better at the higher f. But for the Canon, so let's stick with the Canon here. So at 5.6, the Canon is scoring 100. That's great. The standard deviation is low, which means that the whole frame is in focus. The standard deviation is the distance between the maximum and the minimum. Hello, quick intermission to just clarify that standard deviation is the distance from the mean. So math heads, please don't hurt me, or do in the comments. I mean, listen, you do what you got to do. And so having dramatically lower standard deviation means that more of the frame is in focus. And we see that this continues. We see that this continues at f8. Is there any interesting thing here? So we actually lost a couple. We lost like 6 points of sharpness, going from f5.6 to f8. Here in the test, but that could just be human error. That could just be like bumping the camera microscopically. But you can see that the data is evening out, as in like there's not so much of a stark difference between the Canon and everything else. The standard deviations are going down. If we come down here to f16, which by the way, the Olympus, the maximum aperture on the Olympus is f16, not f22. We see the Olympus at the top, which is insane, and then the Canon is at the bottom. And so like I am just, the maximum values, like the Canon is just obliterated at f16. But also guys, f11 and f22, so it's not just like I just like blew it at focusing or anything like this, at that one stop. So at f16, the Olympus is like still surviving. We still have scores like 71 for the maximum value, like that's pretty good. You know, and so like if you're just trying to take out a vintage lens and just go shoot it, it's great that you can take the Olympus out and just like put it at f8 to f16 and just like blast. That's super cool. Transition Evan here. Let's go back to talking about the Canon. So like I was saying before, it's an ideal walk around lens because most of the frame is just in focus, even at wide open. You know, you're getting really good sharpness values wide open across the entire frame. You know, so if you even do a halfway decent job manually focusing it, you got this. It's just a good lens. It's just a really good lens, and not to mention that especially for a wide angle lens, you can get it for a somewhat reasonable price. I do think that the prices are inflated in a way I don't like, but you know, whatever. And in terms of absolute sharpness, so like just like how sharp can you get relative to other lenses? It's at the top. It's not quite as sharp absolutely as the Contax lenses, but it's also literally half the price. So, but not to the lens's credit. I would say the diffraction is intense. It's more intense with the Canon than it is with some of the other lenses. I honestly have no idea why that is. I don't know what optical formula is leading to results like that. Somebody might ask, like, why did you decide to do this with the new FD model, and not the SSC or FL models, the like older ones? To that, I would say I would love to do that. I do have a limited amount of money that I can spend on vintage lenses before I think my partner will just kill me. But I would love to do those in the future. But I also think that if you need to like get a set of lenses that works, I would recommend getting the newest vintage lenses that like meet your qualifications, because some of these are old, especially like, so for example, the Pentax has pretty serious haze in some of the middle elements, and it definitely impacts the sharpness. We might, and in fact I would love to prove that to you guys, or disprove it to myself, since I'm just like speculating right now, because I also have a really nice copy of a Pentax 28mm f3.5 that I'm looking forward to
like running through the software. And so the 24 that has the serious haze, if I can compare that to a better copy of a Pentax lens, that'll give me an idea of whether or not the software can really detect the haze and whether it impacts the sharpness. So I'm excited to do that. That's where we're going to leave it for today. I know this was a little bit rambly. This is my first video in like 5 years, so forgive me. If you like the software, please give it a star on GitHub. I've only published a couple things on GitHub, and I have no stars to my name. So be the first to give me a star on GitHub, and like and subscribe. I'm definitely going to be looking at all of these lenses individually, and including some zoom lenses coming up, some vintage zoom lenses, which in theory are all bad, but we're going to find out how bad they are and whether any of them are good, and that's going to be exciting too. So I'll see you then. Thanks.